back to my series Monero Deep Dive. Last time we spoke about stealth addresses and integrated addresses and how they are used to generate public keys for an output. And this time we will talk about payment IDs. But first, I have to tell you that I wasn't honest last time because it's not the full truth that what I told you about stealth addresses. There's one additional point, and let's talk about this first, and then come to payment IDs. If you see a transaction on the blockchain, it usually looks like this: out 0 and out 1. So these are indexes of outputs. So you usually have two outputs because, like in Bitcoin, you have to respend the rest of your money if you don't want to spend your whole input on an output. And therefore, you want to generate two stealth addresses, or even if you want to send two separate outputs to a target or something like this, and they have to be different, and therefore you are going to include this index here into your stealth address calculation. It's not that difficult. I will write it down shortly for you. So your one-time address, the stealth address, added by T, the index, is hash of R times the public view key of Bob, and concatenated with T, and T is the index. I guess you can read it better. And T is the index of the output. And then, of course, again, adding the spend key as usual, and here is a G missing. Yeah, so this is as usual, and the only thing that changed is the index. Okay. Coming to payment IDs. What are payment IDs? Payment IDs are used in a scenario where, let's go down this here. So, okay, this is a store, and here are multiple customers. And of course, the store is only taking Monero, so he sells, for example, the same product for the same price. Something like, I'm not that good at drawing, but I guess it's a plant. So the store is selling plants, and each customer is paying their plants, and the store wants to distinguish which customer one XMR and this one also. And the store wants to distinguish which one already paid and which one hasn't paid yet. And in the Bitcoin universe, you would create new deposit Bitcoin addresses for every customer. But this is not that good. First, you have to store all the old addresses. And the most important part, you have to store the private key. The private key in the Bitcoin scenario is stored on the server. In Monero, you already know this concept of having a spend key and a view key. And as you will see in the following video, Monero achieves distinguishing clients from each other just using the view key and providing a new address, but it's not really new. They reuse the already generated keys, the already generated private view key and private key. We don't have to generate new keys all the time. Okay, so let's look into the protocol. I'll go in here because I prepared something. All right, as usual, Alice and Bob. Alice wants to send Bob one Monero, one XMR. Wait. Okay, and Bob generated his private view key, he's calculated the public view key, and the same thing for spend keys. But this time, something changes because he also generates a PID. I call it PID if I mean the payment ID, and this is like 64 bit random. this is a payment ID that identifies Alice. He stores his payment ID in a database and and compares with check. Bob then generates again the address, and this is called integrated address now, because it's not only consisting like last time out of the view and span key, it also consists out of the PID. He then again does some encoding, checksumming, and versioning, and sends this to Alice. Okay, Alice, as usual, generates a random, calculates an uppercase R, which is RG, and then, as shown above, she calculates for each output a hash. Case B. Okay, so far so good. This is nothing new. This doesn't differ at all. And now comes the part that differs a little bit. I will scroll a little bit down so you can easily see it. I will stick to the notation of the specifications, so it's easier for you to follow if you have to read also the specifications. She calculates K-mask, and K-mask is this part here. And where before there was the output number, the output index, but this time there's 141. And you might ask yourself why it's 141. It's 141 because this is a reserved number. It's a payment ID tag, and yeah, it's like a standard, and it's a constant standard. And Bob also knows that this is a special number, and if he wants to calculate a PID, he also uses this number. So on the other hand, it means if you are planning to build a transaction with that many outputs, you might have some side effects. but I'm not sure about this part. Okay, so the next step is she calculates K payment ID. And this part is pretty simple. She simply takes K-mask, and now I will write some pseudocode and chops it to the length of the PID. So just some Python pseudocode. It just if it's shorter or longer, you need to have the same length for the next operation, and the next operation is an XOR operation. So here's the encoded PID, and this is XOR of PID and K payment ID. All right. I will mark some parts for you. Well, wait. First, I will. So this is the PID calculation part. This is new. Alice builds then the transaction, and as usual, she puts in the transaction the stealth address for the first output. For maybe the second output, she also provides R, and now this is new again. She puts the encoded PID in the transaction. And of course, some other part that we're going to cover later. Okay, what is new? New is that we split it. We have two outputs now, but this is not really new. As we can see here above, we just added the index as discussed before. And of course, new is this part, the encoded PID, that is based on the transaction payment ID. Okay, she sends this transaction to the blockchain. And now again, I will scroll down. Bob, after he sent the address to Alice, is repeatedly downloading each block and checks, like last time, if his if his view key and span key fits to a transaction, and if it's fitting it, he say, oh well, it's my transaction, and he will do some other calculations. Yeah, like he will look at the extra field in his transaction, and this is exactly where this PID is located. This encoded PID is located, and after that, of course, he will do. I won't cover this again and how we will calculate the output key or something like this. And of course, he will basically. I will write it here. Here, he will go through each step. So he will first calculate k-mask, and again, since this, and Bob is going to calculate hash of, R and his private key and the known number of 141. And again, this this and this is the same because of this shared secret part of the elliptic curve cryptography, and yeah, so it's the same, and yeah, the next steps are also the same. And if you XOR something, XOR can be used as an inverse function as well. So yeah, what I want to tell you is that at this part, this is the same, and here Bob simply XORs the encoded. PID together with his calculated payment ID, and he gets the payment ID, which is equal to the payment ID he sent, and yeah, that's basically it. Not that difficult. If you have any questions, let me know. Yeah, feel free to ask.